a simple random sample in this question. N is equal to 64. The mean of the population is 175. And find the probability the sample mean is less than 172 when the standard deviation of the population is 4. So we're testing 172 against 175, and we're dividing by 4 over the square root of 64. So minus 3 divided by 4 over 8 minus 0.5 is equal to minus 6. Minus 6 is greater than 3.09, and therefore in that tail, we looked at this in another video, after 3.9 you're just left with 0.0001. I think I put 001 in the last video, but I think it's 0001. So the same on the other side here for less than 172 here. If we have 172 here, this is also 0.0001, so a tiny amount. Bit of a silly question. Well, let's change the 172 to 173. 173 minus 175 over a half is going to be minus 2 divided by half minus 4, so that's still way outside. 174 minus 175 divided by 0.5 is minus 2, so that's still kind of quite a bit outside the 1.96 for us to be within 95%, or to be even a slightly high percentage. We've looked up 2 before, and the Z tables gives 0.9772. So if the question was 174 instead of 172, and I think the answer in the book is based on 174, we're going to get 0.0228, because we're on the left hand side of the average here. Over here at 174, if 175 is the average, in the tail less than 174 is 2.28%. Less than 172, we can see it's tiny amount. Question 5, a random sample of 900 oranges, n is equal to 900. The mean weight, mu, of the oranges in the consignment is unknown. Mu is equal to mu. We don't know the mean weight. The mean weight of the consignment is unknown. So we do. So the mean weight of the sample is 82.4. So the mean weight of the sample is 82.4. Standard deviation of the sample was 12. Well, we can take the standard deviation of the sample to be of the general population with the central limit theorem. Construct a 95% confidence interval for the mean weight of oranges in the consignment. Okay, so our 95% confidence interval. So we're looking for the margin of error here for a population at 95% confidence level, which is 1.96 times 1 times sigma over root n. So in the case of question 5, we have 1.96 multiplied by 12 divided by the square root of 900. That's going to give me 0.784. So I have to add that on to my 82.4, which is going to give me my average for my population, and then I got to take it away, and I'll have my 95% confidence interval. So 82.4 plus 0.784, 83.184, and 82.4 minus 0.784, 81.616 for question 5. Question 6, population has a mean mu and standard deviation 15. Random sample of 400 from this population had a mean of 95. Construct a 95% confidence interval. So we have standard deviation to be 15. My sample is 400, and a random sample has a population of this population has a mean. So the population of the mean, the mean of the population. Mean of the population has a sample of 95. Mean of the population 95. I'm just reading this correctly. The sample has a mean of 95. The sample. So let's construct this 95% confidence interval. We need the margin of error 1.96 multiplied by 15 divided by the square root of n divided by 20. So we're just getting 3/4 of 1.96. I'll write square root 400. It's probably better maths. So by 15 divided by 20. So we're getting 3/4 of 1.96. That's equal to Snooker's maximum break of 1.47. And we have to add that to the mean of the sample. So I'm going to get 96.47. Put them in a bracket this time. 96.47 on one side and 93.53 on the other side. 94, 95, 93.53. If the margin of error for a 90% confidence level is this, construct a 90% confidence interval. Well, this is just more maths here, isn't it? 1.645 by 15 divided by 20. So we're getting 3/4 of 1.645. That's giving me 1.23375. We'll take two decimals. We've taken two decimals here. We'll take two decimals, 1.23. So I'm going to go from 95 to 96.23 on one side, and I'm going to go 94, 93.77. 77. That's 90%. And they've asked us to do a 95% as well. So 2.575, sorry, 99%, 2.575 multiplied by 15 divided by 20. So we're getting 3/4 again of 2.575, and that's going to be equal to 1.93125. So I'll just take 1.93. So we're going to get 96.93. 1.93, 96.93 on one side, and on the other side 93.07. Let's line them up beside each other here, and we'll see, can we spot what's going on. 93.53, 96.47. This one was 95. My 90 was 93.77 and 96.23, and my 99 was 93.07 and 96.93. And you can see here that this side is going, well, it's going down, and this side here is going up. So we start off with the radius of our confidence interval is here for 90, and it widens for 95, and it widens again for 99. And a question was asked one year about the width of the radius of the confidence interval or something along those lines. So it'd be this type of maths involved here. So there's your confidence intervals, 90, 95 and 99.